We are here on this beautiful November 6th in Algebra 2. We are on lesson 3-4. We're talking about dividing by monomials. By the way, what is a monomial with a quiet raised hand? Monomial. Who has monomial for me? Andrea. One term of a polynomial. Thank you, you got some XP there. By the way, before I give you your XP, here we are in our unit guide. We are on 3-4, which means today is Tuesday. Wednesday is divide by binomial. So we're dividing by two terms at the same time. And then on Thursday, we're going to divide by polynomials. Divide by 3 or more terms, or maybe 1 or 2. And then eventually we're going to do the polynomial remainder theorem, then quiz, then test. That's where we are in the unit. Any questions on what we're doing?
You almost wanted to skip like 3 lessons.
I know. I was just so anxious to get to the next lesson. All right, so Andrea, you did get your XP, so thank you for doing that. There you go. There's your 50 XP. I noticed that everyone has full AP, by the way, which means that the Warrior, especially Gio and James, you need to be using your first aid. You're level 3 now. You have that ability unlocked if you want it. Unlock first aid. Be healing yourself. Healers, be healing. Mage, replenish the healer's AP. And we're coming back to notes. That was my slight tangent. All right, so.
Wait, what happens if you die? You go back to level 1?
If you die, you stay at your current level. You get a random sentence like going to Miss Assassin's room or calling home, and every single person in your group gets minus 10 HP. Yes. So, long division. Long division. Help me out here. How do I do 257 divided by 2? 257 divided by 2. 2 goes into 257 how many times? Tell me the steps and why, because we need to use that to help us with polynomials. James, what's the first step?
See how many times 2 goes into 2?
Yep, see how many times 2 goes into 2, and how many times does it go into 2?
1.
1. So I write the 1 above the 2 because that's how many times it goes into it. So James, there's your XP. I do have a pencil. Here is a golf pencil with no eraser. That is your replacement pencil. It is a writing utensil. All right. If you make a mistake, here, Chris. 3, 2, 1, catch. All right. So 2 goes into 2 one time, and then I go ahead and I multiply 1 times 2. 1 times 2 is 2. Okay. But here's the trick. So you're going to be. This is probably the most common error when we do polynomials is to say, okay, 2 and 2. Do we just add those together? No, we go ahead and multiply everything right here, which might be more than one term eventually. We multiply everything by here by 1, by negative 1. So this is now negative 2. Oh man, you didn't even know you were doing that. And then I go ahead and say, okay, I'm subtracting 200 technically, because I'm multiplying by 100, and this is really 200. But that's beside the point. We are subtracting 2 from the hundreds place, and I get...
Wait, why'd you make it negative?
Nothing. Yeah, why did I make it negative? Someone answer that. That's a good question.
Oh, wait, did you subtract?
We're trying to subtract it, right? Yeah, exactly.
We're not adding.
When I subtract 2 from the hundreds place, I am left with no hundreds, and I'm left with 57. I bring them down. Bring them down. In fact, you probably only need to bring down the 5 for now. We only need to bring down the next digit. 2 goes into 5 how many times?
5.
Eva.
2.
So probably 2 since everyone is shouting at me. But from now on, let's do a quiet raise hand. I appreciate how anxious we are to share our answers. And then Eva, what am I going to write next?
You're going to write a -4.
A -4. So I write a 4 and then I make it negative. And then I go ahead and do my subtraction problem. Thank you, Eva. I do my subtraction problem. 5 minus 4. I know that to be 1. I passed kindergarten.
Then you bring down the 7.
And then Chris has it correct. You bring down the 7. He's just so anxious to share and get some XP. You bring down the 7. Now I have to ask myself what's the answer to that question that you are asking yourself, Stego?
8.
Well, what's the question and what's the answer to the question? How many times does...
How many times does 2 go to 17? That's 8.
8. And then I write down
6 minus
16 and I make it negative and I get 1. There it is, Stego. So, Steph, what is this thing? What is this 1? What did we just find here? What is that?
I don't know.
No? You want to give it to someone else? You get a call on someone else. What is that? Steph, you get a call on someone.
Christopher, what is it?
You.
What is 1?
You know. Wait. you don't. There's no
What?
Did you? Okay, Chris, you gonna call on someone.
point. There's a point, right? And then you add a 5.
Oh, there's a decimal, and then there's 5.
I'm not done. You add a 0.
Oh my god.
bring it
Decimal,
down
add the 0, bring down the 0.
2 times 5 cents.
Yes, so that is a correct method of doing decimals. I agree. So, Chris, you get your XP. However, this is the important part. This one, there's an even easier way of writing this. What is this one, Chris, calling someone else? Calling the person that you want to marry? I'm just kidding. Calling someone else?
I was about to put my hand down.
Chris, call on any random person. Close your eyes and point.
James.
All right, good job. James, what is one? James, what is one? What do I call that? It has a name, James. Do you know what that is?
A number.
It is a number. What type of number in terms of this division problem? Starts with an R.
Oh my god.
And if you don't know, you're going to call on someone else.
No.
Say it louder, Chris.
I said that the first time.
That right there
Wait, was I wrong? Why James?
is the remainder. Label it. I cannot spell remainder. We don't talk about Fight Club. Okay, so that is your remainder. So what you say here is remainder 1. Or, better yet, you say and 1/2. You say 1, there's my remainder, and I say divide that by my original 2. This is 128.5. I put this remainder, this was my remainder in yellow, I put that remainder on the numerator, in the numerator. The denominator came from this original divisor. What am I dividing by? I'm dividing by 2, so I put that 2 in the denominator. Are we okay with that?
Sure, yeah.
This 2 went over here. Let's see if we can apply that same thing to a polynomial. All right. So I'm going to divide x squared plus 3x plus 6. I'm going to divide this thing by this thing. So what is the first thing that I'm going to do? Fiona.
X goes into x squared.
And you're allowed to use x's and 2x's and x cubes now. If I divide x squared by x, what do I get?
X.
X. So it goes into x squared. How many times, Fiona?
Once.
No.
Twice.
No.
X.
X times. Yeah. X goes into x times. Because x times x will give me this term x squared. Remember, the whole idea here is we have to find a number to eliminate our hundreds place. We have a number to eliminate our x squared place. So thank you, Fiona. You got some help from your friends, but that's okay. We'll get those friends XP in no time at all. Okay, then do I add those two together? Do I get plus 2x squared? Is that what I'm doing? No. What am I doing? I'm subtracting. Yes, so let's do that. I'm subtracting those x squareds, and what do I have left? Nothing. Nothing at all. James, what am I going to do next?
You see how much x goes into 3x.
Yeah, because you brought that 3x down, and we're checking to see how much it goes into this 3x. And how many times does it go into that 3x, James?
3 times.
3 times. So I'm going to go up here and say plus 3 times. Okay, and then I need someone else. What is the next step here? I'm going to write something right here. What am I going to write right there?
Oh my god.
Good.
Oh my god.
Andrea.
Minus 3x.
Minus 3x. So it was 3 times x to get positive 3x, and then we made it negative. Let's go ahead and do that. 3x minus 3x, Andrea, was 0.
I thought you said 7.
0.
I was gonna say wait.
All right. What is my next step?
You bring down this.
What is my next step, Eva?
Bring down the 6.
Bring it down. Downtown to Chinatown. We're down here at plus 6. And what do I do next, Eva?
See how many times x goes into 6.
Beautiful question. How many times does x go into 6? I will leave that question up to the class. That was a beautiful question by Eva. How many times does x go into 6?
7.
Gio, you got it for us?
X times right here.
x times. So you're saying x times x is x squared. That doesn't quite equal
Well,
6.
I guess you're doing the same thing you do the other one, so it's the remainder divided by x.
Say it again. Say it again. One more
I
time.
don't want to say it again.
No, you had it right. You had it right.
You got it. I'm in.
Remainder divided by x.
So the remainder, you're saying this is our remainder. You are correct. So let's go ahead and label that. Everyone in our notes. This thing right here. X does not go into 6. The answer to Eva's question, you can't go into 6 from x. We're done because that is the remainder. So if that's your remainder, Gio says put that remainder in the numerator. What's the denominator, Gio?
Wait, what?
What's the denominator? That was a numerator. What's the denominator?
X.
X, there it is. So my full answer over here was 128 and a half. My answer here, and I'm going to write it down here again, is x plus 3 plus 6 over x.
You said 3, not 6.
I don't know why I did a 6. Log in your extra credit tracker, James.
It's kind of odd.
Yeah, it's kind
Yeah. Finally got my bag.
Remember that you got extra credit on the 6th of November. Make a note in your notes. Say, I got extra credit right there. There is my final answer. Are there questions on how to divide by a monomial at this point? We're going to try some more practice problems in a sec.
Is that it?
That's it.
That's dope.
That's dope. I agree. It's hecka dope.
How does this help me in life?
You want to set it on my house?
So, in the idea of pure mathematics, it is just fun. It's fun to apply the systems that we already know to existing systems, our existing systems to new systems. It's fun. And if it's not fun to you, that's okay. It's fun to me. I don't know. In a sense, it's kind of beautiful, though, right? You knew, because you've mastered all of this long division, it's beautiful because you didn't really have to learn anything new. You just had to apply this same knowledge to a new scenario. You applied the same knowledge from integers to polynomials. Isn't that cool that you can do that?
Yes.
Whoa.
I think it's cool, at least. All right. So here is our theorem for today, our red star. Can we not stack markers, Gio? Okay, I'm going to assume, Chris, Fiona, I'm going to assume that A and B are polynomials.
Why'd you say it like that?
Because you're putting your feet up and Fiona's not even looking. I'm going to assume A and B,
But I'm looking at the thing.
I'm going to assume that A and B are polynomials. And I'm going to say divide A by B. When I do that division, I'm going to get the following thing. And write this down. I'm going to get some quotient. I'm going to say Q for quotient. Q of x. This Q of x corresponds to this x plus 3. That was the quotient. And if you want to write that right here, you can circle this x plus 3 and say that was the quotient. This Q of x was the quotient. When I divide a polynomial by a polynomial, I'll be left with a quotient, but I'll also be left with a remainder. I'll be left with an r of x, that's the remainder. And that r of x will always be divided by whatever I was dividing by, right? So over here I was dividing by x, so my denominator was x. Over here I'm dividing by b of x, so my denominator will be, quiet raised hand, Gio, b of x. This is our key for unlocking all of our problems today. You didn't even know that was a key and you're already solving problems. This is just making it more formal. And by the way, there's this little note. This note would be in tiny text at the very bottom of the page that you will always forget. The degree of r of x is always less than the degree of b of x. For example, quiet raised hand, what is the degree of 6? What is the degree of x? What is the degree of 6? What is the degree of x? I need a quiet raised hand to tell me both of them. Quiet raised hand. I need both of them. Fiona. And the degree of 6 is? Take a guess. It's actually less than 1. Go for it, Fiona. It's 0. This was a degree 0 term. This was a degree 1 term. It matches this little note where r of x is a lower degree than b of x. 0 degree and 1 degree. Everything matches up so far with what we know. Let's go ahead and try one more example, and then I'm going to turn it over to the backside. This is a Khan Academy example. Both of example 2 and example 3 are Khan Academy examples. All right, example 4. I want us right now to divide this negative 4x to the 5th plus 2x to the 3rd minus 5 by x to the power of 3.
I don't know how to do that.
So I'm going to set this up. Remember that the thing that I'm dividing by, the divisor, this thing, is always going to be over here. So I'm going to write, and I'll always skip a line because you're going to be writing on this line right here. So skip a line, come down here to x to the power of 3, do our little whoop, do whoop. You have to make the sound effect. There it is. Minus 4x to the power of 5 plus 2x to the power of 3 minus 5. I set up the problem. I want you to go through this in your groups. Make sure your group is on the same page. I'm going to be circling around to make sure that we're all okay. We're back. All right. Who's getting some XP? Walk me through this problem. How many times does x to the power of 3 go into negative 4x to the power of 5? Only one person knows. Gio, go for it.
So it goes 4 times.
How many times?
Negative 4 times.
Negative 4 times? Okay.
X to the power 2.
Oh, negative 4x to the power of 2. And what's the shortcut to figuring that out if you didn't know that?
So you basically are subtracting the exponent.
Yeah, you're subtracting the exponents 5 minus 3, and then you have to get that negative 4. Exactly. And another way of seeing it, I'll give you the XP in a sec, is negative 4x to the power of 5 divided by x to the power of 3. That's essentially simplifying to negative 4x squared. That's the number that I'm looking for right there. So if ever you are in doubt, just divide this by that. That's how many times this goes into this. All right. So Gio, there you are. Gio, you got your XP. Next step is to do what? Quiet raise hand. Quiet raise hand. Quiet raise hand. Who has it? Eva.
We would do the plus 4x. Yeah, plus 4x to the fifth.
Yeah, so you multiplied this by this negative 4x squared times x to the power of 3, and you made it a negative. You multiply by negative 1, and then you add them straight down to get 0. Okay. Thank you, Eva. What's next? What's next? I haven't heard from this group at all. We're laughing at Chris or something. I don't know what's going on. What is the next step? Eva wants to go again, but I want to give it to someone else if possible. Andrea, go for it.
Bring down the 2x.
Okay, bring it down. 2x to the third. And how many times does x to the power of 3 go into 2x to the power of 3? 2 times.
Sure.
Thank you, Andrea.
Just making sure.
All right. Next step is to do... Oh, I don't know. I drew a line there. What is my next step? Quiet raise hand. James, was that a hand?
No.
Fiona.
Oh, just stretching.
You see what 2x to the third? Oh, you put that, you subtracted by that.
Yeah, so 2 times x to the power of 3 is 2x to the power of 3, and you subtract it by that to get 0. And then...
Well, I think it's 7.
And then...
And then you bring out the
Fiona?
negative 5.
You bring down the negative 5.
Bring down the negative 5. Okay. Thank you, Fiona. All right. What's my next step? Someone else. Next step is to... Sego.
That's the remainder.
That's my remainder. So my remainder is
Negative 5 over
5 over x to the power of 3. So my final answer, box down here. Can you write it for me again, Sego? It is...
negative 4x squared plus 2 and then negative 5 over x to the third.
And box it. Thank you, Sego. All right. We are on to the backside. The backside is basically the same type of question. I just want to make sure you understand what it's asking for. It's saying, I'm going to take A and I'm going to divide it by B. I'm going to take A and I'm going to divide it by B. That will give me a quotient and it will give me a remainder. It's asking just for the quotient, just for the remainder. It doesn't now care about the B. It doesn't care about this x to the power of 3. It knows that you know that. You always put whatever you're being whatever you're dividing by. Your divisor. So all I need is Q and R. Don't worry about the B. Just Q and R. So same process again, and give me Q and R. You will be writing for your final answer down here, Q of x is equal to the quotient, and you'll be writing R of x is equal to the remainder. That will be your final line. Go for it. We're back on example 2. We have set up our problem on the off screen. Most people are doing this without even writing anything down here because they can easily divide by x squared. So I'm going to do this really nice and quick. Here we go. This is going to be negative 8x to the 4th plus 3x squared minus 4x. And then this 1 is a remainder, so it's going to be plus 1 over x squared. In order to get q of x and r of x, I'm just saying that q of x is equal to all that left-hand side. Q of x is equal to negative 8x to the 4th plus 3x squared minus 4x. There's a little bit too much talking. And then my r of x is equal to 1. I don't have to worry about the x squared because that is technically b of x. All right, and example 3, because so many people have moved on because they're so quick at this, this is going to be x to the power of 3 going into this polynomial, 7x to the power of 7 minus 6x to the power of 6 minus 3, and this one turns into 7x to the power of 4 minus 6x to the power of 3, with the remainder of negative 3 over x to the power of 3. And finally, when I write my quotient q of x, that is 7x to the power of 4 minus 6x to the power of 3, and my remainder, r of x, is just 1. Or just negative 3, sorry. Just negative 3. And I don't have to worry about that denominator because the denominator is not asked for, that b of x. That concludes our notes.